When a strip of red litmus paper is placed on a dry soap, the red litmus paper remains red. Now, a few drops of water is dropped on the dry soap. The red litmus paper turns blue. What can you deduce from this activity?
At the end of the lesson, students should be able to explain the role of water in the formation of hydroxide ions to show the properties of alkalis.
Is water important in showing the properties of alkalis? Let us investigate. Place some dry barium hydroxide powder and a piece of dry red litmus paper in a small beaker. Rub the litmus paper on the powder using a glass rod. What happens to the litmus paper? Now add some water into the same beaker. What happens to the litmus paper? That's right, the litmus paper changes to blue color. Why doesn't the litmus paper change color before water is added? Barium hydroxide is an ionic compound. In solid state, barium ions and hydroxide ions are closely packed in an orderly manner and in contact with each other at fixed positions. Thus, the hydroxide ions cannot move freely in the solid state to exhibit alkaline properties. When barium hydroxide powder is dissolved in water, it ionizes to produce free-moving barium and hydroxide ions. These free mobile hydroxide ions can exhibit alkaline properties. We can write the equation as shown. Let us find out if water is important to show other alkaline properties. Dip 2 carbon electrodes into a beaker containing pieces of dry solid calcium hydroxide. Then connect the electrodes with wires, switch, battery, and electric bulb. Click on the switch to turn it on. What happens? Now, add some water to the calcium hydroxide in the same beaker. Click on the switch to turn it on. What happens now? Record your observations in the table provided. Drag and drop the correct symbols to the empty boxes. From the results, we can see that dry calcium hydroxide does not conduct electricity. Without water, hydroxide ions in dry calcium hydroxide are not free to move. When water is added, calcium hydroxide dissociates to form calcium ions and hydroxide ions. We can write the equation as shown. These ions are free to move to carry electrical charges, and they also allow electricity to pass through. Thus, the alkaline properties can be shown. Can other solvents replace water to show alkaline properties? Let us do this activity. Test tube A contains dry ammonia gas. Test tube B contains dry ammonia gas in trichloromethane. Test tube C contains dry ammonia gas in water. What do you think will happen to the litmus papers placed in test tubes A, B and C? Let's find out. Yes, litmus paper only changed color in test tube C where water is present. When ammonia molecules dissolve in water, molecules dissociate to form ammonia ions and hydroxide ions which show alkaline properties. There is no change to litmus paper in test tube A because only ammonia molecules exist in ammonia gas. There is no change to litmus paper in test tube B because ammonia molecules in trichloromethane remain intact. Thus, no hydroxide ions are produced.
Let's check your understanding. You are given test tubes labeled A, B, C, D, E and F. Your task is to identify which are alkaline solutions. Click to drag the litmus paper into test tube A. If the litmus paper changes color, drag an alkali into the table. If the litmus paper does not change color, drag the non-alkali into the table. Repeat for B, C, D, E and F.
Congratulations!
Let's play the Wheel of Fortune game. In this evaluation, you will be tested. If you are ready, click on the Start. In this lesson, you have learned that an alkali will only exhibit alkaline properties when water is present. Water is needed to produce free mobile hydroxide ions in alkalis to exhibit alkaline properties. Ammonia will only exhibit alkaline properties when water molecule is present.
These beakers contain water sample. When liquid soap is added, they should form lather. But look, only one beaker produces bubbles and the other one produces soap scum. Do you know why? One of these beakers contains soft water and the other one contains hard water. Your task is to find out how soap works in hard water and soft water. Do they have different pH? Get into groups of 5 to search for the answer. Present your finding in a scientific way.